Hi, welcome to Chapter 6. It's Masonry Chimneys. This is our third part of Masonry Chimneys. Enjoy. Thank you very much. Have a good day.
Another essential measurement is the distance from the top of the fireplace opening to the base of the damper, which is called the throat. This vertical distance acts as the initial smoke reservoir and plays a major role in shaping the airflow pattern as the smoke exits the firebox. According to IRCR 1016, this distance must be a minimum of 8 inches for standard fireplaces. Rumford fireplaces, known for their tall, shallow, highly efficient design, require a minimum of 12 inches because they rely on a different aerodynamic profile to accelerate draft and push smoke into the flue. This throat clearance is one of the most important dimensions in the entire fireplace system. If the throat is too close to the opening, smoke has insufficient space to turn upward, resulting in turbulence and smoke being pushed into the room. People in the fireplace industry understand that this dimension is fundamental to preventing smoke spillage, and that correcting this distance is often key to solving chronic smoking problems in older or improperly built fireplaces. In some cases, this minimum throat distance can be effectively improved by installing a smoke guard. A smoke guard is a metal strip mounted across the top portion of the fireplace opening, reducing the vertical height of the opening by approximately 4 to 6 inches, sometimes more. By decreasing the opening height, the smoke guard improves the draft geometry between the firebox and the throat, helping reestablish a proper smoke path. The guard essentially forces smoke to rise more sharply into the throat instead of rolling forward into the room. Smoke guards are often used as a practical fix for fireplaces that were built with openings that are too tall or for fireplaces that smoke occasionally due to marginal throat geometry. Taken together, these measurements, the fireplace opening, the firebox depth, the throat height, and the liner cross-section, provide a complete picture of how well the fireplace is engineered to draft properly. When these dimensions are correct, the fireplace operates smoothly. When one or more of them are incorrect, smoke, odor, and performance problems almost always develop. One of the most important topics to understand and to explain clearly is why firebox mortar joints fail and what the building code requires to prevent that failure. The International Residential Code addresses this directly in IRCR 1015, which establishes the structural and material requirements for firebox walls. Under R 1015, firebox walls must be 8 inches thick when lined with firebrick, or 10 inches of solid masonry if there is no firebrick lining at all. This is to ensure that the firebox contains the extreme heat generated during use. However, simply having thick walls is not enough. The code also places special requirements on the mortar joints inside the firebox, limiting them to a maximum of 1/4 inch and requiring the use of refractory mortar. These requirements exist for a very specific reason, and understanding the science behind them is essential for anyone working in the field. Standard Portland cement mortar, which is used in general masonry construction, is not compatible with fireplace temperatures. Portland cement begins to lose structural integrity when repeatedly heated and cooled, particularly when temperatures fall below about 700 degrees Fahrenheit during the cooling cycle. Inside a firebox, the mortar joints are subjected to repeated extreme temperature swings. They may reach hundreds of degrees during a burn and then cool rapidly afterward. Each heating and cooling cycle causes Portland mortar to expand, contract, and chemically weaken. Over time, it becomes brittle, cracks, and eventually crumbles out of the joints. This is why so many older fireplaces show missing or deteriorated mortar. The wrong material was used. Refractory mortar, by contrast, is designed to withstand the intense heat inside a fireplace. It contains high-temperature ingredients such as fireclay and calcium aluminate, allowing it to remain stable at temperatures far higher than those encountered in typical residential fires. It does not break down during repeated heating and cooling cycles, which makes it the correct material for firebox construction. The 1/4 inch maximum joint thickness is equally important. Thick joints hold more mortar, and more mortar means more expansion and contraction. This increases internal stress and accelerates failure. Thin joints minimize the volume of material exposed to thermal shock and help the firebrick and mortar behave as a unified, stable lining. When teaching this subject, the key takeaway to emphasize is simple. Firebox joints fail because Portland mortar cannot survive fireplace temperatures. That is why the code requires refractory mortar and limits firebox joints to 1/4 inch. Combined with a mandated wall thickness of 8 or 10 inches under our 1001.5, these rules ensure the firebox can safely handle the intense thermal environment it is exposed to. As we continue taking measurements in the fireplace, one of the next areas to evaluate is the outer hearth.